Hello and welcome to this video. In this video, I'll be reviewing the design of a vertical alignment in Civil 3D. This is for the webinar that I did early this year on 7th of January, and brought up a challenge for everyone that has watched the video to redesign the vertical profile, meeting some requirements. I gave some requirements for that, okay, just specific to the road, and I had got some submissions, okay, particularly 4 people did well in the submission, and I reviewed everything. I'm not going to go through how I went through all the reviews, but what I'm going to really do is design the vertical profile following those instructions I gave in the review. So before that, I'll just take a brief overview of what the vertical profile is, and how important it is to design it accurately. So if you see my screen, you will see that there are factors that are considered in the design of a vertical alignment. Okay, these are terrain, type of road, location of drainages, cost, and then intersecting roads. So you want to design a vertical profile in a way that it follows the terrain. Yeah. Of course, you must have cut and fill and things like that. Then the type of road, depending on the type of road, there are design speeds that are required for such routes. So you must have to work your profile in that way. Then location of drainages, there are low points on your profile, and also there's stream crossing the road. You have to provide those spots by allowing enough height for the bus culverts to be situated there. Then we have cost, and we have intersecting roadways. Okay, you want to marry those roadways. So these are some of the things that are ascertained. We have the minimum and maximum gradient, the grade of the road. Okay, this is according to Ash2 Green Book 7th edition, so you can quickly browse that and download it. So there are side distances. In fact, side distance is very important. I'm going to show you a video shortly on how important that is. Then these are where you can find it in Ash2 Book 7th edition, Ash2 Green Book. Okay, we have horizontal geometry. Okay, sometimes we have both horizontal curve and vertical curve in the same spot. It has to be blended so fine so that the driving experience will be nice. Okay, then we have the fourth one, which is drainage. I've already spoken that in the previous slide. Now look at this video that was made by University of New South Wales about vertical alignment and side distance. Now look at how it works. Now a car is traveling at 100 km/h on a relatively flat road. Now it sees an obstruction ahead. Okay, side distance is the amount of space or length of road that is required for it to stop 1 meter before colliding with the obstacle. Now look at this in a vertical profile. When it comes to a crest curve, now you would notice that there is no sufficient space in this case, and it has seen the obstacle, but there is no sufficient distance to stop before it, and it has collided with the cows. And if you're in the north of Nigeria, this is a big deal. If you hit one cow, you're in problem. All right, so okay, here's another instance. It has crossed the vertical curve, so this vertical curve should not be too sharp. Okay, and then it has seen an obstacle. Thankfully it has already applied brake, and it is going to stop 1 meter before the collision. Of course, it must not be, it can be more than 1 meter, but 1 meter is the required time. So okay, so these were the recommendations I gave for that challenge. I said that the design and the existing must tie at the beginning and the end. This is a personal recommendation, and it happens, of course, sometimes, especially when the road is linking to an existing road. So you don't want to make the beginning higher than things like that. So, and also the design and the existing should not be more than 2 meters. Okay, that is the cut and fill. Right, so we should also, since it's 100 km/h, of course, by recommendation the maximum gradient should be 3% and the minimum is 0.5%. So, and then you must not have more than 10 PVIs. Okay, that's point of vertical intersection. So we should not use reverse curves. These were the recommendations. So let me just go ahead and design this road. Already I've made my designs. Let me just quickly walk you through it. Please watch the video if you haven't, of the complete geometric design of this road. Okay, I will post that link somewhere in the video. You would see it, and then you can watch it. So All right, so you would see that I have my horizontal alignment on top of my surface, of course, and then here I have my vertical alignment. I've done the design. Let me just walk you through it, but I'm going to redesign it. Okay, so these are the stations. We have the horizontal, is showing the profile of the horizontal alignment. You know, while I'm designing, it's good to have that in view. Okay, I have the existing level and the design level. Okay, and then I have the difference between these two. Okay, this is showing me my cut and fill, and of which I gave recommendation that it shouldn't be more than 2 meters. Now coming on the design, you can see that I have the gradients. Like here I have 1.16%, okay, which is within 0.5 and 3% as I gave in the recommendation. So yeah, that is it. I have 1% here and along 58 meters of tangent. Okay, if you come here, I have 0.58%. You see, it's almost close to 0.5%, which is the limit. Now, okay, I'm going to just design these routes. Now, before that, I have to set, you know, we are going to be using design code. Okay, but design code does not check percentage. So I have programmed, you know, an extra you know, like on the profile, if on the design checks here, I have something we call, I've programmed. If you look down here, I have maximum grade, it should not less than or equal to 3%. You're right, this is like programming. Like I programmed something that will be checking my profile. So when I add a design check set, I have named that design check to be called FMWH 2013 Federal Ministry of Works and Highway Standard for 100 kilometers per hour. So you will see how I'm going to do that by the time I come. Let me just go you know, to designing. You know, that thing will help me to check it automatically. So if it's less than 0.5%, I will see an error, things like that. So let me go ahead to design this profile. I'm just going to click on this and then press delete. So I've deleted this vertical profile. I'm going to now design it again. All right, so I'm going to just come to my home tab. I'll find my profile. Okay, click on profile and then click on profile creation tool. Notice that we have create best fit profile, which is a nice thing. Okay, you know, to explore, a nice feature to explore. I'm not going to use this feature, maybe because I don't frequently use it. There's another way to do best fit, which I'm going to do in this profile creation. So I'm going to be asked to select the profile view. Okay, now I have to set up some things. Okay, like the name, I'll leave it this way since it's road 1, the name here, the alignment name. So it's going to call it for me road 1 design using this template. So I'm not going to have any description. I have some styles. Notice that I have some of my predefined styles. Okay, if you notice, this is not, you know, how it appears. I've customized some things for myself. Okay, and then I have my own design profile, and then I have my own label set, and also my design criteria. Okay, I'm going to use design criteria. Let me just use H2 you know, 2011 standard for minimum K. Okay, and then I'm going to add extra design check set, and that design check set is Federal Ministry of Works on Highway standard. Okay, since I'm in Nigeria, so I use, you know, our specifications. You know, H2 gives you general recommendation, while in any country you are or even region you are, there are sometimes they give some specific recommendation regarding the roads that are within that area. So I've done some programming there and I've put some things I'll be checking. So I press OK. So I'm going to do some best fit alignment here. I'm going to come and check, look for length. All right, a straight, and I'll choose fixed tangent best fit. Now before I start designing, please, this is one good practice. You study your existing ground profile and then see where you are your potential places of, you know, imputing points of tangent, points of vertical intersection. Now if you notice this road, I might relatively keep this thing straight, that's all the way from here. I will take this road straight all the way from here. Then somewhere here, I can see that I would have a PVI, and then I'll start going up. Okay, I'll go up, and then somewhere here, I'm going to have another PVI. If I'm trying to keep this profile simple, that is okay. I'm going to come down here, maybe have a low point here, since naturally there is a low point here. So, and then I'm going to start going up, and then have a crest here, and then come down, you know, and then tie with the existing, just like in the recommendation. So if that is cool, or else I can also go further into, if I have to follow this profile detailedly, I think I should have also a crest here, then have a sag here. Okay, and then go maybe have a crest here, have a little sag here, and then start maybe take that up, and then you have the liberty, okay, to do that, but I just want to keep this simple, okay. All right, so let me just keep it simple by having just a straight. I'll have a large cut and fill, and then go down up to here. Of course, watching that I don't go more than 2 meters or less than 2 meters, more than 2 meters in cut or fill. So let me check that. I'll click on fixed tangent Backspeed, and then I'll be asked how I want to do it. I'm going to say by clicking on screen. Okay, I'll press OK. So I'll start clicking high and low places. Now starting from here, I'll click here, click this place that seems high, find a low place, click it. Now look what's happening. It's already drawing my design profile for me. Of course, if you have done physics in secondary school, this is line of best fit. It's going to be calculating it within that range. So I'm going to click somewhere high here, and then click this low point, click this high point somehow, click this low point, click this high low. So it's going to be marrying in between this profile already. How cool is that? So click here, click here, click here, just some random clickings like that. So once I'm done with that, okay, if I'm cool with this, I think I'm going to stop here, so that I'm going to have a curve this place that will lead me to this crest here. So if I'm okay, I'll just press enter. It gives me a summary of all those points, and I can influence some things here. I can exclude, pass through. Maybe I have to force the line of best fit to pass through certain stations that I've selected here. Then I can also increase the weight of each of the points if I really want it to be leaning towards a particular place. I can increase the weight of that point, and then this shows me the offset entities. Of course, you can see that I have somewhere more than 2 meters, and then I have somewhere more than 2 meters. Okay, well, let me just keep it that way. At least you understand what I'm doing. If you have all the time and liberty, I don't want to make this video long. I would have taken my time and also start going and be adjusting them one after the other. I can't adjust them here, okay, because this is an automatic calculation. I can only adjust them in the profile later on. So let me close this down. Okay, what happened? Oh, I think there was something wrong. Let me click on that again. Maybe I lost that. I don't know why. I mean, I can't tell why. Let me click on this, on this, on this, on this, on this, on this, on this. Just keep clicking, and then press enter. Okay, you press good. Okay, I have to check it on. That's why I closed it. That's why it went out. Now, good. Can you see an error? I am below 0.5%. This is because of the code I have programmed. So let me do something that would allow me to have more than that. So I think, of course, by recommendation, I should be tying with this. Okay, so as I'm tying with this, can I see that error? Good. I'm above 0.5%. Okay, which is cool. I think I'm okay with that. So now let me go ahead and have another tangent here. So I'm going to click on this, and then by clicking on screen, press OK, and then I'll start clicking. It could be random points, but let them be at least up and down in the undulating nature. So I think if I'm okay with this, okay, I'm just going to press okay. I'm going to now this point seems coming up, so I think I'll just click somewhere below here, so that it could just address that. Okay, using some idea, some sense, you will just click somewhere that will just make it will lean it towards the other side. So fine, if I'm okay with that, I press enter, and then I check okay. So I'm not going to make so much adjustment. So here I would have to introduce a curve. So I'm going to come here and then click on free vertical curve best fit. So I'm going to click on that, select the first entity, which is this, and then select the next entity, this. So I'm going to do that by clicking on screen and press OK, and then click on this, just click randomly along this line, and then I'll press enter if I'm okay with that. Then I'll press good. Can you see how that profile is tying in this vertical profile clearly? All right, so can you see that? That's very cool. So let's go ahead and introduce a tangent here. So I'm going to press this, and then by clicking on screen, I have OK. I'm going to click on this, click on this. I think I'm okay with this. Maybe I have this line. Good. In the case where you have made mistake, what do? Do you exit? No, I'm just going to press enter for now. Okay. Now, what is that last point? I'm going to exclude that last point. I'm going to click exclude. So as you can see, it has excluded that last point, and I'm left with the ones I want. If I want that, I'll press OK. So can you see that that's where it is? So I'm going to now include a curve using best fit. Notice that it's using the last command, which is fine. Okay. So I will just click on this, and then click on this. By clicking on screen, fine. I'm going to have to click here, maybe click somewhere here. Is it too high? No, I don't think so. Okay, click here. Make sure you click until the profile is looking, see if it's tying to each other. So I'm going to press enter, and then if I'm going to okay with that, I will accept it. Now look at it, it has tied. Now this is a cool feature. Okay, all right, so let me press by clicking on screen here. I'm going to add tangents here, tangents, you know, here, maybe add here too, so that it's balanced. Here it's drawing that in the preview for me, and then if I'm okay, I can just press here, just okay, to see that coming fine. So I'm going to press enter, and I'm just going to jump to accept that. Add my vertical, sag. Okay, click on this by clicking on screen, and then I'll start going this way, and then I'll press enter. All right, if I'm okay with that, I'll press yes. It gives me, now look at an error. What's it telling me? What's this error? Let me hover my mouse about it. It's telling me minimum tangent length, okay, must be equal to or greater than 50 meters, and this is exactly what I wanted in the design. I want it to be at least 50 meters. So what I'm going to do is I'm going to adjust this dynamically. I'm just to click on this profile and then draw this out. Okay, now good. Am I up to 50 meters yet? Not yet, obviously. So I'm going to either maybe adjust this one instead. Adjust this one. Okay, sorry. Great. Now the error is gone. That means I'm okay. So I think I can proceed, right? So here I'm going to also, now I must not use best fit here. I already know this is fairly straight. I can use another one. You must not use best fit all the way. So I'm going to just click on this and then tie it to the end. Is that not better? Okay, I'll just press enter. I'm okay with that. So I'm then just going to add my curve. Click on this entity, click on this one. By clicking on screen, I will just click anywhere along the profile. I think I'm fine. I'll just press enter, sorry, and then click yes. Good. Is this not cool? Now this is cool. All right, so if you notice in the band sets, okay, yeah, there is nothing showing. That's because I just recently started designing this profile, so I don't have that. I have to go back and then adjust that in my band set. So I'm going to click on this, right click, and then go to profile view properties. Okay, in the profile view properties, I go to bands. I'll notice that I have profile 2. I must make sure that I make that profile 2 the road 1 design. Okay, profile 2 the road 1 design, and then apply. Once I do that, you're going to see that the road 1 design, the design which is in red, appears, and then the difference starts showing. You can see the differences, so you can inspect them to know if you are within 2 meters and more than 2 meters. So and then you start adjusting your profile. You know, you can use, if you just click on your profile, you would see some buttons here, some shapes, just points here, nodes, where you can use to adjust. If you want to go up, for instance, here you can just drag this up. Okay, now you can introduce point of vertical intersections at any point. Okay, that is, you just come here. If you look at this option, you click insert PVI. Okay, you can insert PVI here and then increase, and then like here you can see that I have 1 2 3, just 4 PVIs. Okay, just 4. Right, I can use up to 7, and remember I told you can use up to 10 in the challenge I did. Okay, so you can use up to 10. This road is how many kilometers? This is like 5 kilometers. So in 5 kilometers, you have just 4 curves. No, it's not. It's even small. I think it's even small. So like I said, I just made it simple. So you probably should follow this profile. Like I should have a straight here, then have a sag here, okay, then continue with maybe another straight here. In everything you are doing, make sure you are not more than, as in you are not less than 50 meters in tangency, in tangent length. So you'll be checking that. Okay, so fine, I think this is cool. I believe you have learned a lot from this. Okay, the video to the webinar of which I draw this challenge from is still available, so you can just go and watch it, and then do your design. I will not review it again because I've already taken the time to review. And in fact, for those that I've reviewed, I have used an Excel sheet, to compare their performances. I have Benga Joshua, Olukanmi Steven, Kasasa Peter, and Philemon Balima. Okay, I've seen how they observed. This is a sheet that showed how I reviewed, how they observed all the instructions, and out of the 10 possible points that they should get, okay, all of them did well. At least they got above five points. Okay, but the highest is Olukanmi Steven. He obeyed all the instructions I gave. However, I have just one comment that some of his vertical curves are too small. Okay, it was almost like a grade break. So you must have the vertical curve should have at least some good length. Okay, not just because you want to fine-tune your profile, you just insert a small curve. No, it will be like a bump on the road when it is during driving. That is and besides, your code should have even flagged that. All right, if you have some checks. So it's good practice as you are designing. Make sure you download Ashto Green Book. Okay, it will help you to guide you in your designs. All right, so and look at the points. Okay, he got the highest point, 9.8, and he's going to get a reward from me. It's good to follow instructions. I mean, try as much as I believe you all engaged yourself, all of you all engaged yourself into thinking how to make that work, with the available constraints. Okay, which is what engineering is all about. You have constraints when you are designing, so you have to follow those constraints so that you have a good design at the end. So I see, if you can just see here, for instance, in the maximum grade, all of them, okay, except Philemon was above the requirement. Okay, and then all right, and also in the minimum gradients, okay, we have two people that observed that. I see that Benga Joshua had 0%, which is not practicable. You shouldn't have a road that is 0% just going flat. We have, of course, some cases we might have that, but it shouldn't be too bad. 0%. No, how is it? If you have side drainages, for instance, what is the slope? It's not going to work. So that is it. Now if you want to see your design, the design, you can just come to toolbox, come to reports manager, and then okay, and then you would find your profiles. Okay, and then go to incremental station with difference. Okay, you click on that, double click on that, and then look for the road, which is road 1. We are talking of road 1 design. You click on road 1 design. Okay, and then you see we have the design and we have the existing here. At what intervals? Let's say at 20 meters intervals. And then I'm going to find where I'm going to save this. Okay, choose a folder. I'm just going to save that in my desktop. Okay, I'm going to call it road 1 horizontal, sorry, road 1 vertical alignment. Road 1 vertical alignment design. Make sure you select that to be an Excel file, and then you save, then you create the report. Okay, no existing, no, just don't worry about this. Press yes. Now watch that come up. It's going to calculate that for you, and okay, and then open that in Excel. Can you see? So you can see that this is my existing elevation design, and then these are the differences. You can see the differences. You can begin to inspect them. Of course, I have something that is more than 2 here, but not too many. Okay, as you can see. Oh, I have much here. I can go back and adjust them. Of course, I've told you how to do that, so keep working until you have something that you want. Okay, so cool. I think I'm going to end the video here. And let me see your questions. Okay, comment, subscribe, like if you want me to be making such videos. Yeah, have a nice day.